December 25th will carry many motivations to commend. It's a yearly celebration remembering the introduction of Jesus Christ. However, in cosmology, that day is likewise the 2-year commemoration of the starting of NASA's James Webb Space Telescope. Humankind's most noteworthy space-based observatory ever sent off on Christmas Day 2021, James Webb has been our enormous workhorse, uncovering the universe in an entirely different light with extraordinary goal and frequency. Inclusion to commend its birthday, James Webb has cosmologists feeling merry, as it recently permitted them to picture a far-off brilliant group of universes they have named the Christmas Tree System Bunch. In this group, the James Webb Space Telescope found gleaming Christmas lights in the structure of 14 new transient items, heavenly objects that light up decisively prior to disappearing. The colder time of year wonderland is authoritatively called Max 0416 and is situated around 4.3 billion light-years from Earth, said Hein Yen, an academic partner in the College of Missouri's Department of Physical Science and Astronomy. We're calling Max 0416 the Christmas Tree Universe group, both on the grounds that it's so beautiful and as a result of the glinting lights we find inside it. Transient objects in space, like individual stars, appear to abruptly light up by orders of magnitude and afterward disappear. These transient items appear brilliant for only a brief time before vanishing. It's like peering through a moving magnifying glass, spotting so numerous drifters in this cosmic system. This was accomplished by combining the JWST with the Hubble Space Telescope. The sheer number of drifters seen in one go, thanks to the pair, implies there are some more yet to be tracked down inside the Christmas Tree Universe group. It's almost like a Christmas present for stargazers that continues to give. The light from the Christmas Tree World Bunch started its journey across the universe when the solar system, now 4.6 billion years old, was just around 300 million years old. Traditionally, this would make it too faint for even the Webb telescope to find exhaustively, but a little trick originally recognized by Albert Einstein made seeing this vast Christmas a bit easier. In his 1915 theory of general relativity, which concerns the concept of gravity, Einstein expressed that objects of great mass should bend the very fabric of existence, united as a single entity called spacetime. This creates a curvature we experience as gravity. When anything, including light, passes through these curved regions of space, its path becomes curved accordingly. When an object passes between Earth and a distant light source, the light from that background object takes a varied amount of time to reach us, as its path is not following a straight line due to the arch made by the intervening object. This can eventually cause that background object to appear magnified from our vantage point. This idea is called gravitational lensing, as the mediating object acts as a cosmic magnifying glass. James Webb has been taking advantage of this peculiarity with great success to see some of the universe's earliest systems, and its perspective on the Christmas Tree Galaxy group is its most recent model. This picture, we can see numerous transients in certain regions due to gravitational lensing, which is amplifying universes behind this group. Right now, we have this intriguing opportunity that nature has given us to get a detailed view of individual stars found exceptionally far away. While we are currently only able to see the brightest ones, if we do this effectively and frequently enough, we will be able to determine the number of bright stars there are and how massive they are. The transients were found by Yen and the team as they were viewing 4 sets of images captured by James Webb over about 4 months as part of the James Webb Space Telescope's PEARLS program. The team identified 2 objects in the pictures as cosmic explosion blasts that occur as stars reach the end of their life expectancies. We are excited by this outcome as we can now use those cosmic explosions to study the galaxies in which they occur, Yen explained. Besides this, the cosmologists also found something else remarkable in the Christmas Tree Galaxy group. A massive star in a galaxy seen as it was when the universe was only 3 billion years old. They have named the star Mathra after the massive kaiju from Japanese film. The galaxy in which Mathra hides was lensed to multiple times its original brightness. The object lensing this galaxy is currently unknown, but Yen and the team estimate it has a mass between 10,000 to 1 million times that of the Sun. Jose Diego, research lead author and a researcher at the Institute of Physics of Cantabria, said in a separate statement, "The most probable explanation is a globular star cluster too faint for the James Webb Space Telescope to directly see. However, we don't know the true nature of this extra lens yet. What's extra interesting about Mathra's galaxy is that it was also visible and lensed in Hubble Space Telescope images taken some time ago. Normally, A lensing object and a background galaxy would move out of alignment over such a period, but Mathra's home galaxy and the object lensing it appeared to have stayed together in the future. Yen and the team hope to both determine the nature of this lensing object and uncover some of its properties. Yen concluded, "I will be able to understand the detailed design of the magnifying glass class and how it relates to dark matter distribution. This is a totally new perspective on the universe that has been opened by James Webb." One of two papers detailing the observation of the Christmas tree galaxy group was published in November in the journal Astronomy and Astrophysics, while the other has been accepted for publication in the Astrophysical Journal, with a preprint available on the Research Archive AR14. Remarkably, this James Webb shot isn't the only Christmas-themed picture in space this year. Just a few weeks prior, a picture of Copia A, the remnants of a star that exploded long ago, was unveiled by First Lady Jill Biden as part of a new White House Christmas schedule. These pictures, and others, follow a long tradition of space experts and other astronomers linking the season of light with cosmic phenomena happening light years from Earth. Yet, there is authentic scientific wonder involved in some of these festive observations. Unlike the Christmas tree galaxy group, Copia A is much closer to home. Researchers have long studied the remnants of cosmic explosions to understand their role in galactic evolution. They help galaxies develop. Danny Milovich, an astrophysicist at Purdue University who studies Copia A, wrote in an email, "Cosmic explosion remnants also create the elements needed to sustain life, like the oxygen we breathe, the iron in our blood, and the calcium in our bones." At 11,000 light-years from Earth, Copia A has been observed by a variety of space telescopes in visible, X-ray, and infrared frequencies. However, Webb's new in April, NASA released a picture of the cosmic explosion remnant using the telescope's mid-infrared instrument. The most recent preview utilizes the telescope's near-infrared camera, which captured gas, dust, and particles emitting at warmer temperatures. The pink and orange structures, surrounded by smoky material against a sparkling backdrop of stars, resemble ornaments hanging from a tree branch. As Dr. Milovich said, "A long time ago, Webb launched perfectly on Christmas morning. At the time, I thought it was the best Christmas present ever, but the telescope is the gift that continues to give. Rared vision provides a better view." What's fascinating is that James Webb isn't the only observatory sending us Christmas presents. A distant star-forming cloud that looks like a turkey escaping a cosmic Christmas dinner has recently been captured in another image by the European Southern Observatory's Very Large Telescope in Chile. The festive photograph highlights the star-forming billows of gas and dust that make up the cloud IC 2944, located around 6,500 light-years from Earth. IC 2944 has a particularly F-like appearance, so astronomers have nicknamed it the running chicken cloud. In the dazzling new 1.5 billion pixel Very Large Telescope image, the wispy gas and dust rings of the cloud sparkle in red, pink, and orange, interspersed by brilliant blue stars like lights gleaming on a Christmas tree. The running chicken cloud is around 71 light-years wide and lies toward the constellation of Centaurus. It contains several isolated regions, all present in the new picture, which covers a patch of the sky as wide as 25 full moons. The brightest area, which appears as the back of this massive bird, is known as IC 2948. This region is filled with brilliant gas and dust plumage, accentuated with radiant blue light from hot, young stars. These stars spread throughout the rest of the cloud as well, cutting this vast chicken by emitting immense amounts of ultraviolet radiation, which scatters gas and dust, thereby assisting in reducing further star formation. However, some regions of the running chicken, known as Bok globules, are resisting this high-energy radiation and are visible as dark, dense pockets of gas and dust scattered around the cloud. Further up the cosmic chicken is a right-angled wing-like structure called IC 2944, which resembles a chicken wing in the act of fluttering. Atop IC 2944 is the bright star Lambda Centauri, which is closer to Earth than the running chicken cloud at just 470 light-years away. The star is so bright that it's visible from Earth with the naked eye. In the upper right of the picture, two emission cloud regions of very hot ionized gas called GUM39 and GUM40 make up the top of the running chicken. A further emission cloud, GUM41, can be seen to the lower right of the picture, forming the foot of the vast The study of star-forming regions like the running chicken cloud allows scientists to observe some of the universe's fundamental processes, revealing the life cycle of stars and their interactions with the surrounding material in the galaxy. The chicken cloud has been relatively stable for many millions of years. Observations from the Very Large Telescope give researchers detailed insight into these processes, helping us understand how stars form and The study of star-forming regions like the running chicken cloud allows scientists to observe some of the universe's fundamental processes, revealing the life cycle of stars and their interactions with the surrounding material in the galaxy. The chicken cloud has been relatively stable for many millions of years. Observations from the Very Large Telescope give researchers detailed insight into these processes, helping us understand how stars form and